Hello everyone. Welcome back to today's video. We're going to start lesson 122. Now, lesson 122 goes into a couple more families of functions, and by now we've gotten quite a few of them, so let's see how we do. So today we're talking about cubed root and absolute value functions. You have drawn graphs of different families of functions, lines, quadratic functions, and square roots. As a class, you saw an inverse proportional graph. Check it out. We got an inverse proportional graph, which was the hot tub. We saw an exponential graph, which was the outbreak. The linear, do you remember what the linear was? Linear was the signatures. Today you will explore the graphs of two additional functions, cubed root and absolute value. By the way, that means as of now, we have actually studied a total of 6 families of functions. Do you know all 6 of them? Right here we have listed 5. Which one's the one that we haven't included here? You should know. You are going to have to be familiar with all 6 of those up to this point, plus a few others that we're going to be adding here in the next couple days. Okay? So let's explore cubed root. Now I'll be honest, this next problem is a little confusing, which is why we're doing it here in class. And so please make sure you stick with me. Okay, here we go. Cubed root. The solution to the equation b to the 3rd power equals 8 is called a cube root of 8. The idea of a cube root is similar to the idea of a square root, except that the cube root of 8 must be cubed. In other words, multiplied by itself 3 times to become 8. One way to write the cube root of 8 is using the notation, and look at this right here, okay? The cubed root of 8. So it looks like a square root with a 3 there on the outside, okay? Now, technically, when we have a square root, like the square root of 9, technically there is a value out here. Does anyone know what it is? It's technically a 2. But we just kind of ignore it and we just assume, hey, if it's not written, you know it's a 2. However, this is the cubed root. And yes, you can have 4th roots and 5th roots and stuff like that. At this point, we're only going to address the cubed root. Now, can you already think about what the cubed root of 8 would be? What number times itself 3 times? Now, this is not what number times 3. It's what number times itself 3 times gives me 8. And the correct answer is 2. 2 times 2 is 4 times 2 is 8. So the cubed root of 8 would be equal to 2 if we wanted that answer. Okay? So, how can this notation be used to write the solution of t to the 3rd power equals 30? Well, it's very easy. We could just think about it and say, okay, well, if I want to, well, how could I do that? How could I find the answer? Okay? We might think, oh, it's the cubed root of 30. But why? Why is that? Why does that work here, okay? Well, technically, we'll look at this problem. Look at letter B. And by the way, make sure you write this down for A. This is 143A. These are your notes for your class, okay? 143A, t to the 3rd power equals 30 is equal to the cubed root of 30 equals t, doesn't it? Now, that works because, well, let's see. Letter B. What is the square root of 64 squared? Square root of 64 squared. Well, the square root of 64 squared, think about it. Square root of 64 is what? 8. And 8 squared is 64. So the square root of 64, all of that squared, equals 64. How about the square root of 19 squared? Well, what's the square root of 19? I don't know. I have no idea what the square root of 19 is. Some weird, ugly decimal, which you could look up in the calculator, but we're not going to because we don't need to. Because if we take the square root of 19, whatever that number be, and then we square it, we're going to end up with 19. 19. Therefore, the square root of 19 squared equals 19. Now, what does that mean? Well, what would happen to the cubed root of 30 cubed? Cubed root of 30 cubed? Well, cubed root of 30, whatever that number is, whenever I cube that, I would get 30. Okay? So the cubed root of 30, the cubed root of 30 cubed is 30. Okay? Now, We want you to understand that so that we know that when I take the cube root of something and I cubed it, I'm going to end up with that value, okay? When I take the cube root of something cubed, it's like these two cancel out, just like the square did over here, okay? And over here, they cancel out and we're left with the value there. Now, if we actually use the calculator to find the value, the exact cubed root of 30, the weird thing is, well, what do you think it is? Can you give it a guess? Give a guess as to what the value is. What do you think the cubed root of 30 is? Well, the cubed root of 30, ready for it? Is 3 107 thousandths, approximately, okay? 3 107 thousandths. Because if you take 3 times 3, you get 9 times 3 is 27. That's a little bit low, that's fine. But 3 107 thousandths gives you 30. Cool. All right, moving on. Now, this next part, problem 144, I am going to do letter A for you. You are going to finish letter B on your own, okay? And we'll talk about letter B here in just a second. So, 144A. Lydia wants to know what the graph of a cube root function y equals the cube root of x would look like. And that's actually really cool. It's kind of interesting to kind of try to guess what the roots would look like, what the graph would look like. All of these families of functions have a different shape, different design, and that's what we're trying to figure out is what do you think it would look like. So, help Lydia by making an XY table. All right, we can do that. What values of x could you choose between all the way from negative 150 to positive 150 to make all of the y values in your tables integers? What are integers? Positive and negative whole numbers. Everyone should take a few moments on his or her own to think about how to create some values for the table. So we are making a table of x and y values, but the x is going to be all the way from negative 150 to positive 150. Now, of course, I'm not plugging in all the values. What I'm trying to think of is what key values might I put in here in this table that would work, okay? And then with your team, put as many integer x values between negative 150 and 150 in your table as you can. So that's what I want you to think about. So I'd like you to actually pause the video and try to think about how can I figure out some x and y values that would work for this table, that would work for the cubed root of x and give me y values that are whole numbers. Got it? All right, so think about it for a second. When you are done, unpause this video and see if you are right. Okay, so you should have unpaused. What do you think? What do you think we could do in this situation? Well, here was my thought. If I just started putting values in here, like negative 150, I would then have to go to my calculator and find what the cubed root of negative 150 was and find out, oh, that's not a whole number. So how about negative 149 and negative 148? And so on and so forth. It would take me forever. So what if I didn't start with x values? What if I started with my y values instead? So for example, what if I started by putting 0 down here? Like what? How would that work? Well, if I know my output is 0, remember what we just talked about? If my output is 0, if the cubed root of some number of x equals 0, what would that number have to be inside there? Well, if I cube both sides, doesn't that cancel out and I'm left with x equals what's 0 cubed? 0. Oh, so when y equals 0, x equals 0. How about if I did the exact same thing and said instead of that value equal 0, what if I said it equals 1? Same thing, that cancels out. So the value of x is going to be the same as the value of y cubed. So if I started with my y value of 1, what's 1 cubed? Think about it, careful. What's 1 cubed? 1 cubed is 1. Because 1 times 1 is 1 times 1 is 1. And then what if my y value here was 2? Same thing. 2 cubed. What is 2 cubed? 2 cubed is 8. So when y is 2, x is 8. When y is 3, what is that value then? So in other words, what I'm doing is I'm actually finding values down here for x that I know are going to be whole numbers. I know these numbers are going to be whole numbers because that's what we're starting with. Instead of finding x values that work and then trying to find the cubed root of those x values, why not start with the y values and cube them to get my numbers here? Okay? And so what I'd like you to do is I'd like to finish off the positives and go into can we go into the negatives? Would that work? So take a second and do as much of the table as you can and then unpause it and see if you're right. Okay, if you unpaused it, here we go. So 3 to the third power. What's 3 to the third power? 3 times 3 is 9, times 3 is 27. 4 to the third power. 4 times 4 is 16, times 4 is 64. 5 to the third power. 5 times 5 is 25, times 5 is 125. How about 6 to the third power? Well, 6 times 6 is 36, times another 6 would be 216. Wait, that's a little too high, isn't it? We only wanted to go from 150 to negative 150, so we can't go any farther. Now, going backwards, how about negative 1? Can that work? Can I have the cubed root of a number be negative? Can a number times itself give me negative? Well, let's try. What number times itself gives me negative 1? Well, negative 1 times negative 1, let's put it this way, equals positive 1. But then if I multiply by negative 1 again, I end up with, does that work? So can I find the cubed root of a negative number? Apparently so. So the cubed root of negative 1 is negative 1. So negative 1 is negative 1. How about negative 2? Can the cubed root of a value be negative 2? What do you think? Okay? So the cubed root of something being negative 2. Well, if we look over here, we could say, it's probably negative 8. Does that work? Does that work? Negative 2 times negative 2 is positive 4, times negative 2 again is negative 8. Yes, ladies and gentlemen, we can find the cubed root of negative numbers. It would be the negative values there. So I'm running out of room here, so you can assume, based on this and some symmetry ideas, even though it's not necessarily symmetrical once you do the graph, you'll see what I'm talking about here. We can assume that if I had negative 4 over here, and negative 5, negative 4 would be negative 64, and negative 5 would be negative 125, right there. And that is the values I can work with. So I can work with that by finding the y values first, and then cubing them to get my x values, okay? All right, so your task now, ladies and gentlemen, what you are going to do now is you are going to answer question B. And question B states, what you're going to do is you're going to make a graph for this. What you're going to do is you're going to make a graph. And the graph, I'll put it up here so you can see. Okay. Question B says, right here, create a graph of y equals the cubed root of x. Scale the axes, the x-axis from negative 150 to positive 150. Refer to your list of graph investigation questions from lesson 121 to help you completely describe the graph. Be as detailed as you can. Now, we have talked about this, guys, and you did it for homework, and we discussed it in class. We actually have the list that we did in class today, and you should be able to use that list. I want a full description of it. So you're going to make the graph. You're going to see what it looks like. X-axis needs to be from negative 150 to positive 150. You're going to graph it and then completely describe it. Got it? All right. Hope that makes sense. Good luck. I will see you tomorrow.